Hello everybody, welcome. This is the part 2 of my video on how to create a hardware VPN client using Raspberry Pi Zero. Last week I prepared the Raspberry and in the meantime have configured my VPN server. The VPN server is a little bit beyond the scope of this video. So what I did home, just quickly to summarize, I have two providers. So what I did was I set up the VPN server using the second provider, my backup connection. So the Raspberry Pi connects to VPN out to the first provider and comes back through the second. And to avoid IP conflicts, I created a new VLAN for the VPN client. So if you go to IP address, you will see that USB 0 is connected to the Mac Pro. So the Mac Pro has 192.168.7.3 and the Raspberry has 7.2. I'm connected to Wi-Fi on my normal guest VLAN 61.102. Through that I go to the internet and I come back on the tunnel on 192.168.63.2, so that's another VLAN. And of course, the tunnel interface is a default gateway. So if you go to traceroute.google.com, you will see that I'm indeed using the VPN connection. Now I need to share the internet connection from the VPN interface to the USB connection. The first step here will be to install UFW. It doesn't come installed by default, so we can just issue sudo apt-get or apt if you prefer that, install UFW. It is very important not to enable it yet because the firewall is set by default to deny everything incoming. You can check the status by issuing UFW status, and I don't even know why I was using sudo before because I'm logged in as root. You see that it's inactive, and we're gonna keep it that way for now. The first step here is to allow SSH to make sure that we're not locked out of our session. For now, I'm gonna enable it for all interfaces, but later we can be more specific and allow it only for the USB Ethernet interface. Just issue UFW allow 22 TCP. And we also need to allow access to our VNC server. Okay, 5900 TCP, so let's just do that. Yeah. By the way, here, we could have also used UFH allow SSH, that would also have worked. I'm not sure if it's doing any deep packet scanning that will know that you are not using something else over port 22. I'm not familiar with UFW all that much. You can do either way. Now we should be able to enable UFW enable, and well, it's going to disrupt the connections. Let's try that. I should be able to log back in. I'm going to exit here and make sure that I can reconnect before I proceed any further. When you enable firewalls, it usually keeps the existing connection. So let's see. I managed to log back in. We are all good. And we can see what ports are allowed by issuing UFW status verbose. You see here I'm allowing TCP in on port 22 and 5900 from everywhere. Later on we are gonna be more specific. And let's see if we can reconnect to VNC. Yeah, it works. So we are fine for now. All right, now I'm going to be more specific with this, and I'm going to start with port 5900. I will disconnect VNC, and I will stick to that before I confirm it works, for only then do the same thing with port 22. So VNC is using TCP on port 5900 and only from the IP of my Mac Pro USB interface. We still have it allowed everywhere though, because there's another rule to 5900. So if we issue FW status numbered, we should be able to delete the rule number 3, and that is the one that allows VNC from everywhere. That's gonna make our Raspberry Pi more secure, so people don't try to log into it when you connect to a public network. So let's just UFW delete 3. Now we should still be able to log in via VNC. But how can we be sure that it's only working on this IP? Easy. So what I can do is, let's do IP address. And I also have 192.168.6.1.102. I should be able to ping it from my Mac Pro. I actually not, because it's blocked on the Raspberry. But we can still do here. And the connection files. Well, I'm in a different VLAN, so let me just remove all the 5900 rules and try one by one. Nope. Can I do this? 1 and 4. Let's do 1. Now let's remove 3. I should not be able to connect via VNC now. Yeah, so the firewall is working fine. So let's go back here and add again the VNC rules from 7.3. Now it should work. Works. Let's do the same for SSH. But let's do first the allows and then remove the others. So let's do, we can insert number 1 from 192.167.3 to port 22. That's list numbered, and let's remove the other SSH rule. So let's remove 3. Let's remove 4. There's no 4 now because I deleted it, so let's just see what we have. Alright, so now inbound connections are all blocked except for 22 and 5900 from my USB interface. And I should still have my VPN. Looks good. So let's continue. Now we're going to configure masquerading to be able to route traffic from the VPN interface to our USB Ethernet port. So first thing, let me just remind myself of what's the VPN interface. You have this tunnel 0, so let's go to Vim or your favorite test editor. We open the rules and let's go to the end and add the masquerading rules. There's a lot of stuff here already. I haven't spent time to look into it. Multicast plug and plays. If you have IP auto discovery, you can just connect to raspberry.local. We can leave that for now. Anything for net? No, we don't. So let's go net rules, net. And now we're going to forward traffic through the network interface of the VPN tunnel. So we do a post routing to the interface. What was it again? There we do for now. Now we need to keep in mind that UFW forbids packet forwarding by default. So we need to change the before chain in the file only for the IP range of the network interface of the USB port. We go back to that file. All right, here should be a good place. So the source network now. So 926.870.24 accept, and again with the same destination. Now if we disable and enable the firewall, we should be good to go. Okay, I can see I've made a silly mistake here. So what happens is I need to call this, add this to the end. Oh god, I hated this visual mouse reporting. This has to come at the end. And I need to commit it again. So let's just fix this. Commit. And these I can remove for my configuration file. And let's try to enable it again. Good. There's one more thing that we need to do before the system actually forwards traffic. So we need to go to sys, or the sysctl file, and we need to go to IP forwards, this one, and enable IPv4 forwarding. I'm not sure if I will need to restart the whole system to be able to get this to work, but just in case, let's restart. I've just restarted the Raspberry, and I can confirm that VPN works, right? and that my USB interface is also up, and that I'm connected to Wi-Fi. So I'm going to turn it off and simulate how it would be if I had this on a public network. I'm going to first enable the captive portal on my home router, then turn the Raspberry off, connect it to my laptop, and let's see what happens. As you can see, I have no interface except the Raspberry, and I noticed I did a mistake. Actually, you have to turn on the forwarding of the packets, so the last options in the the IP forwarding configuration, right? The bottom of the configuration file, that you have to run after you connect to the network, otherwise you're forwarding packets anyway. I'm skipping that now because if you made it so far, you understand the technical implications, and if not, I'll put in the description below. You can just run the commands on IP tables after you connect to the VPN. But for the sake of our video now, I'm going to assume that I enabled IP forwarding now only after I connected to VPN, right? So let's just go back to the beginning and connect to VPN. So let's do, all right, so let's do sudo open VPN and as you can see, I actually didn't manage to connect to VPN because the captive portal is blocking my connection. So I go here, I try to open anything like, I don't know, Google. So far I'm actually not connected to the internet at all, yeah. I'm gonna log into my captive portal. VPN is up. Oh, actually, I was wrong, so I don't need to enter the forwarding commands later on because they are enabled only for the tunnel interface. So it would not do anything for any traffic unless the tunnel interface is up. Let's go here to a new tab and just trace Google to see if we are going through the tunnel. Yes, we are. Now, in theory, well, let me just close the browser to get some CPU time for routing. If I open a new browser, it connects, and I think I should be going through the Raspberry now. Ooh, nice article of the day. Anyway, I'll bring a new command prompt and let's do a trace route Google. And yes, I'm going through the Raspberry. So I'm safely connected to the internet. The Raspberry doesn't start routing packets until I have the tunnel up. So I don't even actually need to touch the IP tables configuration. It's cheap, easy to do, and you can browse safely in public spaces without risking leaking any packets before your tunnel was up. I hope you enjoyed this video. Thanks for watching, and I'll see you next time.